Welcome back to the workshop once again. We're going to continue taking a look at power series representations of functions. In our last example, we looked at this same function and found a power series representation centered at 0. It had a very nice comparison to the geometric series that we were able to make immediately. In this case, we want to find the power series representation centered at 3. So we want to write this, we want to write the power series in terms of x minus 3 to the nth power. So what we'll want to do here is we will want to write this in terms of x minus 3. To do that, it really isn't too bad. So we just make a few manipulations. So f of x is equal to, we already have that it's 1 over 1 minus x, so we just need to change this form a little bit so that way it's still a geometric, the sum of a geometric series, but then have it in terms of x minus 3. So I'm going to write this as 1 divided by 1 minus, and I need x minus 3. But of course I can't just subtract 3, so minus 3, add 3, and everybody's happy because the 3's cancel out and we have the same thing. So I'll distribute the minus sign to this 3 to give me 1 over 1 minus x minus 3 minus, so we get a minus 3 there. Now with that, I can combine these two terms to give me that this is 1 over, let's see, negative 3 plus 1 is a negative 2 minus x minus 3. So we're still looking pretty good, but let's not forget what the form of the sum of geometric series looks like. So just maybe over here, the sum from n equals 0 to infinity of a times r to the n. So this is the form of a geometric series. And the sum is a over 1 minus r. So I need to have something in the numerator, don't care what it is, as long as it doesn't have our x there. So some number in the numerator divided by 1 minus something that involves r. In particular, since I'm looking for it to be centered at 3, I need this r to involve x minus 3. So I'm getting pretty close here. I have something in the numerator, but this value is not 1. So I'm going to multiply the numerator and denominator by a negative 1/2 to make this a positive 1. So I'm going to bring this over to continue my manipulations. Multiplying the numerator and denominator by negative 1/2, I obtain 1 minus. Now you might say, Dr. Reynhout, you need to take the product of the negatives, right? Minus and negative gives us addition. But again, we want to focus on the fact that we need 1 minus r. So I want to leave that subtraction there. So 1 minus negative 1/2 times x minus 3. And now we can see that it looks like the sum of a geometric series. Some number in the numerator, our a value, divided by 1 minus our r value. So if we let a be equal to negative 1/2 and r be equal to negative 1/2 times x minus 3, then that gives us that this can be represented as the sum of the geometric series of a times r to the n. So without any simplification, this is exactly what we would have. Okay? And that's acceptable. There's nothing wrong with this. If we wanted to simplify it a little bit, we could notice that we have negative 1/2 times negative 1/2 to the n. So here's one factor of negative 1/2. Here's n factors. So we have the sum from n equals 0 to infinity of negative 1/2. Here's 1, here's n factors, so n plus 1 times x minus 3 to the n. So now it's maybe a little bit more clear that we have a power series representation centered at 3. Again, if we use the fact that R is this, we have convergence for the absolute value of negative 1/2 times x minus 3 is less than 1, which gives us a radius of convergence of 2. Since we're centered at 3, this gives us an interval of convergence from, let's see, 3 minus 2 would give us 1, 3 plus 2 would give us 5. Again, because it's a geometric series, we know that when this absolute value is equal to 1, then we have divergence. So we do not include 1 and we do not include 5. But that gives us exactly what we were looking for, right? We have f of x is this as a power series representation, and the interval of convergence is also given. All right. I'll see you guys again for another example soon here in the workshop.